let's grade this. Take your pencils, put them away. Get out something with which you can grade. Like a red pen. Or like a red pencil. Or a blue pencil. But not one of these guys. You can't grade with that. So put it away, off your desk, hide your pencil, so I don't mistake you for a cheater. Anybody need something bigger? Now, for this first function, 2x squared minus 4, you should have a pretty good idea of what it looks like already. What kind of graph is that going to be? Yeah, it's a parabola. You've got the x squared. And so, for a rough sketch, basically, this is the amount of detail we're looking for. There are the axes. And I know it's a parabola. Does it go below the axes? Yeah, it crosses at -4 specifically, right there. Okay, so there's my rough sketch. So that's A. B. Just from looking at that rough sketch, I should be able to give, this is my domain. My domain, which for a parabola would be -∞ to +∞. It works for all real numbers. You're not going to end up with any square roots of negative numbers or zeros underneath fractions from this equation. C is my range. So where would my range start? Yeah, -4. And it goes from -4 to +∞. Would we include -4? Yes, we would. Okay, I should talk about how to grade this. That would be helpful for you. So if you got the wrong type of bracket, anywhere, any bracket that is incorrect, we'll take off a quarter point. And we're going to count each question as a single point. Then I'll scale it down when we put it in the grade book. But for now, there are 20 questions, so your answer is going to be something out of 20. So if you put the wrong bracket, that would be 20. If you put something like the y value, the x value of that point, which is 0, instead of the y value, then we'll call that 1/2. Yes, sir. It's on your desk. Yes, ma'am. I didn't say which notation to use. I don't know. Let me think about it. How about a quarter point? Bad notation. Okay. D. What's D? Oh, continuity. Where are there any breaks or jumps in the graph? Asymptotes. Poles. No. So then it's continuous all the way from an x value of -∞ to an x value of +∞. Neither included. E. Is my graph increasing anywhere? So we should be able to look at it and see where it's increasing. Where is it increasing? On the right side or the left side? Yeah, the right side. Even though both arrows are pointing up, remember that's not what increasing means. We've got to read it from left to right. So we've got decreasing then increasing. And we want to give this interval as an interval of x values. So at what x value does it start increasing? Yeah, an x value of 0. And again, if you put the -4, which is a y value, instead of the x value, take off a half point. Also, we do not include 0 because our graph is not actually increasing exactly there at the value of 0. It's not. It's doing neither. It's not increasing or decreasing at that point. So similarly, we won't include the 0 in our interval of decreasing. So it's decreasing from -∞ to 0 to an x value of 0. Again, we want to put the x value there, not the y value. Okay, questions so far? Do we see a relative min or a relative max? I see one. It's right there. So, we have a relative min. Now, some of you may be thinking, hey, I thought that was an absolute min. It is. It's both. That can happen. So it's a relative minimum. It is at 0, -4. I confused myself for a second. Question? Questions? So this is a point. It's not an interval. This is how we say where a point is, right? So where is that minimum? It's at 0, -4. It's right there. It's that one specific point. And then for a relative maximum, there's not one. You didn't have to write that out. If you just didn't write a relative maximum, that's fine. So that would be a half point apiece. Did you get the right relative min? And did you not make up a relative maximum? A half point for each of those. Okay. What about an absolute minimum? Do we have one of those? Yeah, it's the same as the relative min. So it's relative because it's at the bottom of the hill. It's the lowest point in some little area. But it's also the absolute minimum because it's the lowest point on the entire graph. It's both. Apparently I'm not good with the alphabet. I'll work on that. Okay. So the absolute minimum is 0, -4, and then is there an absolute maximum? No. It goes on forever, up and up. There is no highest point where it stops going up. So, none. And again, that'll be a half point apiece. A half point for writing the right minimum, and then a half point for not putting a maximum, because there's not one. Alright. Any questions on those? We're all making 100 so far? Alright, good. Here we're doing the average rate of change on this interval from 2 to 3. And 2 and 3, what kind of values would these be? Yeah, they're x values. This is our x1, this is our x2. So when we're writing out the slope formula, which is what we use here, we've got our x1 and our x2, that's like 3 and 2. And then on top, we need to know what f of 3 are and f of 2. Now, to get f of 3 and f of 2, of course, we just plug those into the function. So what would f of 3 be? Help me out. 14? And what would f of 2 be? 4? So 14 minus 4. And then on the bottom, we get 1. That's 3 minus 2, right? Good. Questions? I hear a lot of low mumbles. You can ask a question if you want. It's okay. I won't be mad at you. So that's 10 over 1, or just 10. Which means our function is doing what there? Yeah, it's increasing. It's got a positive slope, a positive rate of change over that interval. So it's going up. Now, for j, we've got an interval of -3 to -2. Now, without actually even calculating this, which we would calculate the same way, these are my x values, I contend that I already know what the slope is going to be. Not because I worked it out earlier, but because this graph has a certain type of symmetry. What type of symmetry does this graph have? Yeah, it's symmetric across the y-axis. So the interval from 2 to 3 is a mirror image of the interval from -3 to -2. There's mirror images of each other because this graph has what that y-axis symmetry. So the slope's going to be -10. Hooray, symmetry. Okay. And again, you would work it out the same way with the -2 and the -3. Now, one thing, if you came up with the +10 again, you probably messed up on your signs. So that would be, you'd say like -2 minus -3, which is going to make it a plus. And then you'd get a -4 minus a -14. Or you could set it up in the opposite order if you want to. But it should still work out the same way. So the way I set it up, I get a positive 10 over I get a, what did I do? Did I switch? What? Yeah, but I wrote something down wrong. Apparently. Because I'm getting a positive 10 over a positive 10. Did I put those in the wrong order? Oh, right. Yeah, because those are both positive. Okay, thank you. So you get a positive 4 at negative 2 and a positive 14, which gives you a negative 10. There we go. Over positive 1. So negative 10. Okay. So that is all of number 1. Alright. Any questions on grading these last ones? If you just messed up on like a negative sign or something, just take off a half. If you didn't know what average rate of change meant, so you left it blank, then take off a whole point. Okay. So we're gonna have to look at we're gonna have to look at number 2 a little bit harder. So for number 2, our function was 10x cubed minus 30x squared plus 10x minus 5. And let me graph that. I don't know what this one looks like off the top of my head, although I have an idea, because the biggest power of x is x cubed. That's going to tell me the basic shape. That's something we'll talk about later in the year. So 10x cubed minus 30x squared plus 10x. It's important here that you actually type the equation in correctly, or else it's going to make it hard to answer all the rest of these questions. So if I go to my standard zoom, what do I see? A graph is correct. Now, can we tell from just this picture the basic shape of the graph? Not mine? Is your calculator better than mine? Or did you change the zoom? Okay. Alright, so if you can't tell, it's going to look like this. So it's going to come up and then turn around, and then somewhere down here, it's going to connect and come back up. So it's one continuous graph that kind of looks like this. Now that's kind of hard to tell from this original picture, right? And so what we need to do, so here's my rough sketch, is find this point down here where these two parts of the line connect. So I see I might have a relative maximum right here, but is it just going to be a gap in between those? No. My graph is going to connect. So let me zoom out. What do I get if I zoom out? Does that give me a better picture? Kind of. Now, if I remember what I saw on the graph before, I had a little maximum right here near the axis, and so maybe we can intuit from this that it goes up, then comes back down, and then goes back up one more time. If not, maybe I'll zoom in. I'll zoom in on a different spot this time and see if that gives me more detail. Okay, so there's a little bit better picture. So I zoomed out so I could see more of the graph, and then I just zoomed in where the interesting stuff is happening, so I can see it for the most part on the graph right there. So I've got a max, I've got a min. Now, there's my rough sketch. B. So can I tell from this what my domain would be? Are there going to be any gaps or holes, anything like that? No. So the domain is everything, negative infinity to infinity. The range. What's my lowest point? How low does my graph go? Yeah, all the way down. So negative infinity, and then all the way up to positive infinity. So there's my domain, there's my range. They happen to be the same. It doesn't always work out that way. Okay. Next is continuity. So for continuity, we're looking for jumps or gaps, breaks, holes, Anything in the graph that would make us pick up our pencil if we drew it? Do we ever need to pick up our pencil to draw this? Nope. You could draw the entire graph without picking up your pencil if your arms were infinitely long. E. Where is our function increasing? Good question. So, we can see that this section of the graph is doing what right here? Yeah, it's increasing, it's going up. And so, it's going to start increasing from negative infinity on the x-axis, but we need to know what the actual x value is right here. Okay, so where does it stop? Does it stop increasing at 0? No. So how do I find what that point is where it stops increasing and starts decreasing? What kind of point is that? Yeah, it's relative maximum, and I can calculate what it is with my calculator. So I'm going to go to second calc. I want to find that maximum. We worked on this yesterday. I don't just want to guess where the maximum is. I want to get my calculator to tell me. So I'm going to go somewhere to the left, set a left bound, and then somewhere to the right. Where's my cursor? Oh, there it is. Somewhere to the right, set a right bound. And so my maximum is at, and this is actually G, so I'm going to skip down, write this down. Questions? Alright, so I have a relative maximum at 0.18 and negative 4.11. And I'm just going to go ahead and write this down here so that I can refer to these. Now I also have a relative minimum. We can see the relative minimum there. So similarly, I'm going to get my calculator to calculate what the minimum is. Second calc. We are. But remember, the max and the min are where my function switches from increasing to decreasing or decreasing to increasing. So there's a left bound, there's a right bound. My minimum is somewhere in between those. Hit enter one more time. So my minimum is at 1.82, and then negative 25.89. Something like that. Okay. So then my function, we said it increases starting at negative infinity, but then it stops increasing at that maximum. So what is the x value there? From negative infinity to what x value? Yeah, 0.18. And then it decreases from the maximum to the minimum. So that's part F. We're going to have another spot where it increases, so I'll put a U. It decreases between those two. So what are the two x values between which it decreases? So it starts at that maximum, right? So that's on F. And then it decreases until it gets to an x value of 1.82. So that's between the maximum and the minimum. That's where it decreases. And then it starts increasing again. So it increases from an x value, right here, of 1.82, and then all the way to positive infinity, like so. So, if you just looked at the graph and guessed, like I specifically told you not to do yesterday, then count off a half point. You can put like 0 and 2. It's not 0 and 2. It's 0.18 and 1.82. Okay, so there's E. Again, all of these brackets would be open brackets because it's not actually increasing or decreasing at either of those points. And we answered G along the way as well. So we have a relative min and a relative max. And they're each worth a half point. Okay. Questions on any of those? Zach? How did you do? So there are 4 numbers there, so how about a quarter per number? Yep. Yes, but it's guessing much better than 0 and 2. Well, it depends on how close. Those aren't very close. Probably what happened, maybe what happened is maybe you graphed it wrong? Double check how you typed it. Okay. Is there an absolute max? Is there an absolute min? So there are none. Neither of those. If you made one up, it's wrong. Okay. Now we get to the part where we calculate slopes. So first I have an interval from 2 to 3. And again, these are my x values, x1 and x2. And so to calculate my slope, sometimes I call it the average slope. We're going to subtract the x values on the bottom, and then I need the y values on the top. So, what's an easy way to find f of 3, considering I already have it graphed in my calculator? Do you remember how? Yeah. Trace 3. And f of 3 is 25. Thanks, calculator. That was a lot easier than me doing it by hand. And I need f of 2 as well. Trace to negative 25. Okay, use your calculator. That's what it's here for. And what's 25 minus negative 25? Good. Not 0. Also known as 50. Yes. Okay. So we would say this is increasing or decreasing over this interval. Pretty fast, pretty slow. Probably pretty fast. Okay. Now let's do J. So here our interval is negative 3 to negative 2. Now, is it going to be negative 50 this time? No, our graph isn't symmetric. And also we can see that to the left side of our graph it's increasing. So we should get a positive number here. So my average slope, I'm going to use my x values. And again, it doesn't matter what order you do it in, as long as you're consistent. I usually put the one on the right first and then the one on the left second, because that gives me a positive number on the bottom. And I like positive numbers. And then on the top I need f of negative 2. I'll ask my calculator and it will tell me negative 225 minus, and then I need f of negative 3. Again, calculator, negative 575. Now, I know I'm going to get 1 on the bottom. That's negative 2 plus 1. What about on the top? Yes. So we would say our function is increasing or decreasing there? Yeah, it's increasing. It's got a positive slope. Increasing pretty fast. Yeah, for every 1 unit it goes to the right. For every 1 unit of run it rises 350 units. Generally considered pretty steep as far as slopes go. Alright, so there are 20 questions. Whatever you missed, whether it was a quarter point here and there, maybe a half point, subtract that from 20 and give your grade as something out of 20. For instance, 17. That doesn't mean your grade is 17 out of 20. Count it up yourself. Zach. On these? On the slopes? Let me look at what you did. You mean you got different y values?